Find dy over dx by implicit differentiation. To make my calculation easier looking, so I want to write y prime for dy over dx. So y prime means derivative of y with respect to x. Okay, so what we do is always we take derivative of left hand side with respect to x, and same thing in the right. When we do this, we have derivative of y and cosine x squared. So there is no sign, means a product. Same thing here. So we use product rule here and here. So what is that? U times v is u prime v plus v prime u. So let's do that. Let me put that at least. So derivative of y. Okay, this derivative is with respect to x. So when we have y prime, this is not 1 because we are not finding derivative with respect to y. So this is in long form dy over dx, and that is what we are trying to find. But when we have x prime, that's derivative of x with respect to x, and this is 1. Okay, look at the distinction. Y prime is what we are looking for, and x prime is 1. So here, using the product rule, so I got y prime second factor plus derivative of second factor, I'm going to do in the next step, times first factor. In the same way, let's use the product rule here in the right hand side. So I have derivative of x 1 times cosine y squared plus derivative of cosine y squared times x. So y prime is y prime, we just keep here. So this derivative, so we need to find derivative here and here. As we know, cosine of something, cosine of some function of x, when we find its derivative from the chain rule, negative sine u, that's the inside function, times u prime. Okay, same thing. So let me go and do that. So y prime is y prime because that's what we are trying to determine in this question. So y prime cosine x squared plus, for this I'm using this formula that gives me negative sine x squared times derivative of inside u prime, which is 2x times y, is equal to, for in the right hand side, 1 times cosine means just cosine y squared plus this x, let me write here, okay, this x I'm just writing at first. Now derivative of cosine u, using this chain rule, we're gonna get negative sine y squared times derivative of y squared. Can someone help me? What is derivative of y? What derivative of y squared is? I mean, this derivative means with respect to x. So this would have been 2y, but since we are finding derivative with respect to x, we need to multiply by y prime. Y prime means dy over dx. So this is negative sine y squared times derivative of y squared is 2y y prime. Okay, here we just wrote 2x because 2x x prime is same as 2x, unlike 2y y prime. Okay, because x prime means derivative of x with respect to x is 1. So derivative part is now done. Okay, there is nothing left to differentiate. All we do next is isolate y prime, because we have asked to find dy over dx, which is y prime. And if you look at closely, y prime is here, this is y prime times, and where else? And here. So we want to gather these two terms in one side, then other in the other side. So this is negative impact at the beginning here. So I'm gonna bring this to the left side, means I need to add. Okay, so what I'm gonna do here is bring to the left, means add, and now with y prime, and move this to the other side, means this is negative, means we add plus. So that makes we have y prime cosine x square already in the left. This is negative of this, we have to add. So plus, let me write correctly, 2y y prime x, let me write in this way, 2x y prime. I'm writing this 2x y prime and sine y square. Okay, equals this cosine y square is already in the right. Now we are moving, we are adding, that means this negative becomes plus 2xy sine x square, 2xy sine x square. Okay, now we factor y prime. That was the purpose of bringing this term. So y prime out, that leaves cosine x square plus 2xy sine y square equals these two terms, not doing anything here, cosine y square plus 2xy sine x square. I'm just copying this here, and now I need to divide both sides by this junk to isolate y prime. So y prime equals this cosine y square plus 2xy sine x square all over this factor cosine x square plus 2xy sine y square. Okay, final. This y square here is, this is cosine y square. Okay, this is y square as well. Final.